Login accepted.
Hi, everybody. I'm Chayim. We're going to talk about, before it's too late, finding real-time holes in data. And what we're basically going to focus on is understanding their differences to the pipeline and the architecture you might look into putting in place when you're talking about a big data pipeline, actual changes you may make to your code base, a technique, that sort of thing. The idea is that you're getting bits and pieces you can take with you, and we'll see how this goes. Cool. So I'm Chayim. Honestly, I'm a gigantic nerd. I've been doing startups for about 20 years. I'm currently at Redis. At Redis, I manage client and ecosystems. So if you use Redis and you write data to Redis, you deal with my team in some way, which is very cool for me, which means you probably hate me a little bit, and I'm okay with that. I promise you sarcasm. I promise you really bad jokes. There are going to be some pictures, a little bit of Star Wars if you like Star Wars. If you don't like Star Wars and you like Star Trek, I'm sorry, I'm the wrong guy for you. And ubiquitous, we're hiring. So if you want to do development pick your language in order to communicate with Redis, my email address is there for a reason, hit me up. If you want to see that managing a team meets writing code, check me out on GitHub. If you are not interested in clients but want to do something else at Redis, let me know, because I'll figure out how to get you to where you want to go if that's your bag. So here's the deal. Data, it's never clean. We kind of hope it becomes clean. A lot of us have probably subscribed to things like Quandle, which ultimately makes an effort to take a bunch of things, normalizing them down to some sort of set that you can use, and then at the end of the day, trying to make it useful. I think anyone who's ever tried to deal with anything recognizes that doesn't happen, right? If anyone's played with a clean data set, I would like to talk to you because it's 20 years I'm in, I still don't. I'm going to tell you a story. In 2010, one of the largest stock exchanges in the world melted down. This is something that the extreme majority of the planet didn't know about, except for like 15 of us. I'm not going to tell you about the exchange, but I'm going to tell you about the pain. The reason we melted down is we had a series of hackers come in and do two different things. Number one, replace some of our code. And number two, actually change the API layer to not enable sending data to all of the places. Why does that matter? Well, you're a stock exchange, so the way you really make your money is selling your data to other people, right? Whether it's the tick, so the pricing between the bid and the ask, you want to buy something, you want to sell that same thing, that's how exchanges make their money. They sell their data feeds, and we ended up in this humongous problem, which is the largest stock exchange in the world, or one of them, sorry, and our data isn't good, our data isn't useful. We're talking about real time, so this impacts the markets, and you have to change things in real time. Unfortunately, it's 2010. We don't have any of the techniques, any of the technologies we have today. Realistically, do you know what people were trying to do back then? Kafka, producers, consumers, praying it would work out. Eventually you end up with some sort of consistency. It ends up being delivered to a consumer. You ingest it, life goes on. That was state of the art. I think for a lot of orgs, that's still state of the art. Some people are dealing with Zookeeper a little bit. That's great, but we can definitely take that a step further. And the reason, All right, the reason we can take that a step further, or need to, is because dealing with data is hard. Y'all tell me if you can't hear me. This is what a data pipeline ends up looking like, really, really simplified to a lot of folks. If I have event logs or security logs, they're going to go into what I'm going to call centralized logging. So if you're in the security world, you have a SIM. If you're managing servers, you probably have, let's say, a giant syslog server. You get things into Elastic. That's that part of the pipeline. Files go into object storage. So what do I mean? I mean you're throwing things into S3. You're throwing things into blobs. You might be using Minix. Eventually, you get your data into real-time storage in some sort of a buffering way. And then you hit your first layer of databasing. So cool, it's in Elastic. Now I have to shard it all out all over the place. Or awesome, I'm throwing it into my SQL. I need to do things to it. And you go layer to layer to layer to layer to layer. And one day, depending on the type of company you are, you probably build analytics on top of it. You've got a Tableau dashboard, some Microsoft BI. You do something in Grafana. If people are with me, yeah? You've been there? Cool. Do we all hate this? Does this ever work? Yeah, no one smiled. That's right. So here are the problems. First of all, everything comes in a different format. You might produce a CSV, you might produce some JavaScript, that guy over there gives me some XML. You guys are the exact same service, and for reasons I don't understand, I get random smatterings of things that don't make sense. Then we've got different sources. So today, I'm getting everything from api.nasdaq.com. Tomorrow, congratulations, it's now dataset.nasdaq.com. And the day after, you know what, that's changed again, and that becomes problematic and painful. My personal biggest problem is service reliability. There are very few services that are actually 5 nines. That would be 34 minutes of downtime a year. So I remember in 2001 when I started in this pain point, people paid for 5 nines. And I've noticed, you know, over the last, let's say, couple of years, people pay for 3 nines now. That's over 1,000 minutes of downtime a year. So your pipelines are going to be broken, guaranteed. And if you need to care about real time, that is a humongous pain point. We go further. Transformation's a problem. So a lot of organizations, a lot of companies, you know what we do? We take all of these things that we receive, we kind of try to normalize them, right? So your data might look this way, your data may look this way. You know what I'm going to do? I'm going to kind of build a schema. I might throw it into some SQL so that I can query it later, because everyone, like my wife writes SQL, everyone can write SQL. That's kind of the baseline in tech nowadays, I think. My wife is not in tech, by the way. She writes SQL. And then, you know, what do? We sample it, right? We take a random subset of the data that's there. We go, all right, it looks okay. If we're really good at what we do, we write some tests and feel fantastic because we have tests. Yeah, so then we end up in this problem. I still have multiple data sources, but at least they now all kind of look the same. That's a step better, right? I'm going to store the raw thing somewhere, maybe temporarily. I might transform it along the way, so now what's going into MySQL or what's going into Postgres or pick your database of flavor, great, I'm going to store that. I'm then going to enrich it. So that person in the back over there, turns out that she needs some piece of data that you could calculate on the fly, or we could store it at the ingestion point. So I'm going to change my ingesters to take my data and enrich it to add new bits and pieces. I'm then going to store that enriched data, depending on how I scale. This is better. Either in its own database, in multiple locations, and then cool. I'm going to throw a UI on top of it so that people can see it. I might throw some APIs there for folks. I might go further, and if I'm really awesome and I have a bunch of different sources, really awesome does not mean I like this, but you go very cool, you write some GraphQL, and now everyone hates you, myself included. Not because GraphQL is bad, just because, like, honestly, I can't write a good GraphQL server to save my life. So that's painful. But then there's the other set of problems, right? We're just trying to get our data in. The next set of problems, well, I need to normalize my data storage, so okay, I can write a schema, I can throw things in SQL, I can pick some other thing, that's fine. I want to unify my presentation, so that's when you go down that path of, am I going to build an API for this? Am I going to try to make something that people can query with GraphQL and go down that path that way? Like, that's doable. Maybe I'll make service definitions, so I'll actually throw out a whole bunch of microservices and let you stick them together in your application the way you want to, which is kind of a little bit more painful, because now not only do I have to track what's going on with regards to my data, but I now have to care about the service layer and some service mesh, and invariably, I just have duplication of data somewhere along the line, right? I'm grabbing all of the names of the cities in Poland as my example, because I downloaded some library for something I was messing around with, and it turns out that, of all things, Krakow was there twice. So great, now I have to filter my data in some way. That makes it hard for me to share what I have with other people and to collaborate, and that's where we're going to go down. So a lot of people end up looking at this like they have two sets of choices. I'm just going to store my raw data somewhere. It'll be fine. I'm going to go over it repeatedly. I'm going to iterate on it. I'm going to parse it. I'm going to clean it. I might restore the raw data, but like that's kind of okay. That's a normal path people take. Most people take the second path. I'm going to store the parsed data, and I'm just going to deal with the outcomes. So later on, as things change, you know what ends up happening? I have to deal with it. I have to roll with it. So now I have this problem that, okay, I've made one of these choices. What everyone here has done, I hope, is in some way you monitor it. So you're like, cool, I'm going to figure out the number of queries per second that my database is taking on inserts so that I can know if I have to scale that out. I'm going to build some Grafana dashboards just on the operational impact of pulling information into my world so that I can work. This isn't actually what my business is. My business is about I don't know, selling pet food. My business might be about selling stock exchange data. My business could be about anything, but now as a company, I'm spending all of my time dealing with the impact of trying to get data in so that we can actually do the work we care about. Ongoingly, at least, that helps you investigate. You might throw some Prometheus on there. You may start to get some alerts. And it becomes lather, rinse, repeat, right? I think we've all seen orgs, I know I've been parts of them, where eventually this problem, like just this part of the problem, just the monitoring, now becomes someone's job, and then it becomes an ops team, and we're kind of really far from what we're trying to do, which is get data in so that we can go solve whatever problem we're trying to solve. And that's kind of where we're missing the point. So we all look at data pipelines, we all look at bringing the data in, and we say, cool, you know what, these are my problems. I'm not getting it fast enough, speed's a problem. Cool, it's not right, accuracy is the problem, right? Like, it turns out that my data provider never gives me everything I'm paying for. My example of that is when I look at stock market data, so I've got like a nice small data set of around 20 terabytes, and it turns out, shockingly, that one company buys another company, and all of a sudden their ticker symbol changes, right? Fitbit is now bought by Google. So what happens when you want to look up Fitbit's historic stock pricing? Do you get that from Fitbit? Do you get that from Google? How does the graph end up looking? What are the share prices? Do people aggregate that? Do people cut it differently? That's the accuracy problem. My favorite example of this is like go to Yahoo, pick a company that's been bought by another company, and try to understand what happens with a stock split. Sometimes a company, let's use Apple as an example, will say our shares are worth $1,000. Cool, today we're going to cut them in two. I've got 2 shares worth $500, so I have the same amount of stuff. But my graph looks like this because it just got cut in 2, right? I go up, I come back down. It's problematic because if I'm dealing with the data side, if I'm the developer in the room, I can't do anything with that. All of a sudden, I have a humongous hole in what I'm doing. Then we say, all right, environments are the problem. You know what? As a dev, I need something in staging that I can muck around with. I need something on my desktop that I can muck around with. I'm not able to touch all of these things that are in production. What do I do here? And then there's this other big piece, which is actually what the business wants. Enrichment is the problem. So I have the fact that Apple's stock split into 2. It was $1,000. Now it's $500. I don't know if these are real prices, by the way. But what's happening from the business perspective is like, all right, so I guess we're going to go multiply that by 2 because I have the total number of shares. Okay, let me go back. Now I better find a way to get the number of shares that are in the stock market because that wasn't something I had. So now I'm all the way back to accuracy or my environment being a problem. And like, as a dev, I sit there in the room and everything's fine. It's on fire, it's fine. Like, we all freak out, life goes on. It's a 4 a.m. problem, right? Or we could kind of look like at data like it's code. So my pipeline is programmable. That's a really big difference. We've heard a lot of awesome talks. I just went to one, actually, on distributed transactions. And there were some great talks about doing things like Spring Cloud Functions and how I might throw this into, let's say, an AWS Lambda. But I'm kind of far away from my data and my database at that point in time, so how do I look at my data as being a set of programmable items? This is a sloth, if anyone didn't get that. So it's a really slow animal, but people love them. I didn't get that. I have a daughter for that. So we're going to speed up by slowing down. What does that mean? We're going to take a pause. Real time almost never means real time. There are cases where it does, but most orgs say, cool, I have real-time data, which means I'm kind of okay with a 5-minute delay. I have real-time data, I'm okay with a 2-minute delay. That's not real time. Real time is I'm going to get a response in well under 100 milliseconds. Real time is ad bidding networks that have 40 ms in order to complete a bid. And in that 40 ms cycle, the bid happens, the ask happens, the ad gets sold, the fulfillment happens. So if you can't do that in real time, you are not real time. 5 minutes is cool, it's the future, but it's not real time. So we're going to slow down to do the right thing. We're going to prep things so that we can be real time. And honestly, we're just going to like lather, rinse, repeat. We're just going to keep doing this over and over and over again so that it becomes boring. And then data's code, because code eventually becomes boring and we hope to do something new. Oh man, okay, not a cool theme, sorry. So this is how you build your software differently to solve these problems. Store the raw data. Just keep it forever. I don't care where you store it. You want to throw it in S3, you want to throw it into Redis, total bias, throw it into Redis, by the way, done. You want to throw it on a hard drive and lock it in your closet, and somehow you've got like this awesome Lego Mindstorm that moves hard drive physically from A to B. Amazing. Store the raw data, because 100% of the time you need the raw data later, and you've thrown it away. Now parse the data in real time. And by that, I mean, it's great that we're storing that raw data, but we're going to chunk it up exactly like we would, and we're going to think about schemas, and we're going to store it just like we are, but we're keeping the raw first. We're going to bulk our changes. A lot of people don't know, regardless of the database server you're using, at the end of the day, you can take sets of changes and group them together. If you're in the SQL world, you can do a bulk insert. If you're in the NoSQL world, you can do your equivalent. I only know the Redis world, to be honest with you, so you can do a whole bunch of MSets together, and that works. But like if you're in Elastic, you can do a bunch of posts to an index, and life goes on. But bulk changes are huge because, well, there's a cost reduction. We'll see that. And number 4 is the piece that I see most orgs never doing. And it's honestly the thing I'm anal retentive about. I have a pipeline. I'm pulling my data in. When am I scheduling my backfill? How am I constantly re-importing all of the historic data I have? We look at that and say, it's not really possible, right? But I've got a reasonably small subset at 20 terabytes. I can pull that in every single day. No problem. So ongoing testing of that pipeline, ongoing scheduled backfills, even of pieces, it's a big deal. We're going to, I wrote scheduled backfills twice, sorry. We're going to sample. So instead of taking a look at the data only during the insertion point, only when I'm investigating the pipeline, we're actually going to ongoingly sample our data. And then that last one says we're going to scale horizontally and try to do something highly availability. A lot of people end up vertically scaling, and that's understandable because of the databases people have used in the past. But if I can do something where I have a ton of tiny throwaway nodes, throwaway infra, that means that my ability to scale is honestly easier. So how do I store data in real time? Right to a real-time database. I'm not going to tell you which one, but the idea is I need the cost of my writes to be nil. I can't have the impact of my writes be the thing that's slowing me down if I'm going real time. And if I'm writing and the time to get back an insert is a minute, 5 seconds, that's a lot of time. That's a lot of time that's lost to the notion of real time. If I can store that unparsed, unstructured, raw result, I can do something with it. I don't have to deal with it today. I can ongoingly deal with it, right? It can become a development problem that I can code and that I can get rid of. And the third piece, and this is huge, we're going to reduce the cost of network transit. When I look at a TCP packet, I've got 1,492 bytes in a TCP packet. If I'm storing data in that packet and I'm using something that's HTTP backed, as an example, I'm immediately losing, what is that, 23%, I think? If I'm storing something to an NFS-backed world, I'm losing another 11% on top of that. So I really have to pay attention to my network layer. As a total aside, I've got friends at a company you may know called Google. And one of the things they found when we were doing some hacking together is the cost of HTTP requests was the highest cost in their transactional system, because the actual cost of the protocol itself is something like 152, 156 bytes. I never get that right. So they took the web servers. We chunked off the hello. We chunked off to what we could say is the minimal amount of data that we could pack in a packet and say, cool, like my response is okay, I got a 200. And we could get down to 42 bytes. For those of us paying attention, on 1,492 byte long packets, I immediately increased my performance by 10%, right? And all I did was slice out some protocol pieces that internally I don't need. If I'm presenting it to the internet, it's huge because your application uses the protocol in ways I don't care about. You might do some sort of bulks around it. You might send ongoingly requests between byte sizes, but internally, I don't have that problem. So we can reduce those costs in interesting ways. We're going to store our parsed data in real time. Here's the deal. Duplication, like copying things all over the place, is free. I don't mean it's AWS free, like pay 12 cents a gig. I don't mean it's free in that it takes no time, but I mean it's free in that depending on how we build our applications, it doesn't cost us anything. I write somewhere, it replicates, we're cool, life will go on. I can separate my threads, I can store my parsed data, and depending on my choice of application, my main loop, it just kind of keeps going, keeps pulling things in, life goes on. If I'm in a nice microservice, microtransactional world, the last statement has no impact to the world whatsoever, which is my pref. So bulk changes, Hulk changes. That was the best Hulk I had. We're going to batch our inserts and updates. So what that means, if you write SQL, you can take an insert statement and you can glom them together and you can throw them all at the database at once. Why does that matter? Single transaction. Pros and cons, so think about our apps, think about what we're developing. Are we okay with a single transaction? Am I okay with the notion of, sorry, not single transaction, single call. But am I okay with the idea that this may all fail and the whole world lights on fire? I'm okay with it because we're going to talk about scheduled backfills. But today you may not be okay with it. So you have to think about that. If I want to trigger an update across the board because yesterday the company was called B&B Hotel, and today the company is now called, I don't know, Green Fire Extinguisher. That's a single update. Maybe. Could be 1,000 updates. Bulking them is where we get that back. And we reduce the network cost. So if I'm sending 1,000 queries, let's say at a minimum there's 1,000 packets, but there's a packet size problem. Well, if I can cut off the cost of the sends, I can pack those queries together, forget the protocol story with Google, forget HTTP, forget binaries, forget changing your ARC. Realistically, I'm just going to save some time immediately because of the cost of the network. So that's all right. Now we're going to schedule backfills. And we're going to see bits and pieces of this, don't worry. If I don't show you code, I mean, honestly, who are we kidding? So we're going to schedule backfills. So async, which to be honest is something I'm horrible at. If we delay our jobs in that they run on a scheduled time period somewhere and they backfill our data, that becomes huge. Why? Because it's not just a thing that's importing data in my pipeline and it's up and now I'm monitoring it. I actually have other jobs that go through other workers. And what ends up happening is those functions reschedule backfills. That becomes really powerful because one of those ways we scale horizontally is throwing out more of those workers and coordinating work between them. We're going to do timed data enrichments. So what does that mean? Rather than, cool, I'm going to throw it into my pipeline. And on the import of my raw data, remember that I'm now parsing and I'm throwing it over there because that's a great thing to do. Well, I'm not really going to do that. What I'm going to do is I'm going to have a delayed job, something that runs elsewhere, not within the thread of the main way I'm getting data in, whatever your way is. And those jobs are going to do the enrichment. And we're going to look at an example. And jobs that fail, honestly, they can reschedule themselves. There's different reasons that jobs fail. I had this morning, honestly. It really irritated me. Sometimes they fail because, our code is broken, right? Sometimes they fail, in my case, because S3 is very temporary blips if you're throwing a lot of data at places, and you get 500s all over. So by having a job schedule its backfill, maybe have a number of failures before an alert gets generated, that sort of thing, all of a sudden what happens is I can take this, I have my raw data to deal with, iterate, let the business change what it wants later, which is great, because now I'm making it possible to do that, which I couldn't before. But more importantly, my jobs, because they reschedule, when they fail, we sleep, and at 4 a.m., we don't get phone calls. And I hate being called at 4 a.m. I don't ever want to see a 4 a.m. unless I haven't seen my pillow yet. And tons of tiny jobs, right? Once you're throwing things to workers, and once you're having functions that coordinate themselves, what that means is whether it's something as simple as saying, cool, well, in the database it's Apple Computer, and I really want it to be Apple Computer Inc. This is a bad example that's contrived, but we'll go with it. Then that tiny job at some point in time can go change all of the Apple computers to Apple Computer Incs. And rather than it be a one-off, where you know what I'm going to do? I'm going to update the entire table, and Apple Computer becomes Apple Computer Inc. No, it's a function that kicks off. And it runs in the background. In Hebrew, we say matai shehu, once, whenever it has to happen. And we're okay. If there's only one thing you take, the word matai shehu is awesome. We're going to always be sampling, so we're going to keep rereading. We're going to store them. We're going to stream them. We're going to do it in processes. Things that fail are going to schedule these backfills. Oops. And then we're going to scale horizontally. See, Star Wars. Those are clones for anyone who didn't get that. We're going to build. We're going to have many. We're going to scale out. We're not going to scale up. All right. So, show me the money, right? These are these 6 pieces. Here's how we're going to get there. Real-time database. We're going to get real-time data from a financial API. I'm going to show you things that are in my 20 terabyte data pipeline. We're going to buffer into this real-time database. We're going to enrich our data. We're going to sample those backfills. We're going to scale it out. I don't have a great example of number 6, to be honest, because showing Terraform on a slide deck doesn't work, to be honest with you. This is going to be in Python for 2 reasons. One, I really like Python. And number 2, the reality is I've seen a lot of Java, which is awesome, and I like to be exposed to new things. So this is just a new thing. If you don't like Python, I am sorry. All of this applies to Java. So we're going to end up looking like this. We're going to write our data to Redis, possibly because I work at Redis, but also because it's hard to actually say that I'm running things where my code is. How many of you have written a SQL function? All right, cool. And your SQL functions, they don't just trigger. They don't just happen. I mean, some of them can trigger, but they don't just happen. They become part of your select statements, right? So now they're a computed thing that occur when you're trying to get your data, but that's actually really expensive. The advantage of what we're going to see here is we're able to start to async a series of things to modify our data. So I'm going to write to my real-time database that I'm calling Redis. Redis might backfill traditional databases or other types of databases if you need them. So if you have applications that are built on SQL, great, throw data to Redis, let Redis write to your SQL, keep doing what you're doing with your presentation layer. Your API, humans do what they do. In our world, we're going to keep sampling them. When samples fail, because they do, we're going to schedule backfills. An example of a sample failing is I've got tons of ticks using this stock example. So what's a tick? It's something that occurred per second in the stock market, pardon me. So at 2 seconds after 9:31 a.m., someone bought Apple 100 shares at, what's our example, $1,000. That's a tick. If I'm unable to get data from a tick, I'm going to reschedule the backfill of that tick. I don't care why it failed. I care if it's failed 10 times maybe, but I want to push that on my provider, quite frankly. I don't want that to be my problem. All right, so let's talk about real-time replication. Here's how I do it. Here's how we do it. Here's how a lot of people do it. Translate this to what works for you if this isn't how you want to work. We run Redis. Redis gears and Redis JSON are modules of Redis that apply. Most people, myself included until I joined Redis, and I've been using it since 2010, think that Redis is just a cache. And by that I mean like wicked. Set a key, get it later, cool, I have your session, right? I fully admit that I've been at Redis for like a year and a half. I didn't know it did anything other than that. Full disclosure, turns out we've got like modules that do JSON and real-time search, but gears with JSON is fantastic. We install dependencies, and we configure what's called a write-behind recipe. And that's part of this magic where we saw previously, you write to Redis, and it throws to your databases. Redis write-behind, or rgsync, and if you use the Java tools, it's rghibernate. So one is Spring-enabled, one is Python-enabled. Pardon me? What they'll do is, you write to Redis, it will write to your database. If you want to write to Mongo, have fun. If you want to write to Postgres, have fun. If you write to Microsoft SQL, none of us care, right? We want to enable you to do that however you want. And I didn't tell you this, but I checked I'm allowed to. If you want to write JavaScript, that's also coming this year. The laziest way possible to do this is with the Redis mod image, which is just all of the stuff bundled together. It's the tip of the tip of the tip. It gets to be broken. We kind of have to accept that. I get in trouble when it's broken, so you know who to email. That's where we're going to go. This is a Python write-behind recipe. So I'm bringing in the thing that will write to JSON. I'm connecting to Mongo just because I wanted to show you something completely different. And I'm writing my data to Mongo. That's it. So I receive data, cool. I'm connecting to Mongo, awesome. If I store something in Redis with the prefix person, that means person Bob, person :1, person potato. I don't care, just prefix it person. I throw my JSON into Redis. That's why I care about Redis JSON, because most of the world is JSON. I don't like JSON, but I don't like anything, so it doesn't matter. I get my data into Redis. Redis offloads it to Mongo. The level of who uses this for scale, I can't say who, but I can say, since I had to do it for them, there is more than one Israeli governmental agency that uses this. I don't necessarily know for what. My guesstimate said it was for corona tracking, but I don't know for sure. I do know that more than one agency uses it. So we're talking about abject scale. We're talking about being able to both get that buffer that I care about in real time, so my applications can throw the data they receive to Redis. Redis can buffer that data back out to, let's say, Mongo, and replace Mongo with MySQL. There are ways to do this. And if you want the Java side, again, the word you want is RG Hibernate. And what that allows you to do is with Spring-based configuration. So I'm not even talking about writing code. I'm going to go write me some Spring, write some Hibernate XMLs, and let it do its thing. Huge. So what's the right behind? If you're from the Python world, we create a virtual env. A virtual env is really an environment that is segmented and segregated just so that I don't have to worry about dependencies. I don't know how much of a problem this is for others, but I've seen a lot of companies where we just throw everything. All of our jars go into the one magic folder, and we really hope things don't conflict. And then they conflict, and then we throw Dynatrace on top, and then we start to debug. Python, we have these virtual environments. The idea is that folder over there, you have just the dependencies you care about. That folder over there, you've got just the dependencies you care about. So it's a nice way to achieve isolation. And we also use that to achieve isolation of versions even, so that I can start to create applications and split out the versions of Python I'm playing with. Gears CLI, this is a package that allows you to interface with Redis Gears effectively via the command line. It provides commands for you to do so, which means you don't need to learn the Redis language. And I say that because I work at Redis, and I don't like the Redis language. It feels a little too, what's the word I'm looking for? Prior to C, in memory, starts with an A. I can't get there, I'm sorry. But I also don't have my notes, so I wrote that down. Anyways, that's what it feels like. You can install your dependencies. So if your recipe, although it should not, does enrichment along the way to the JSON that you receive, cool, go do that. If you want to take a pandas array and slot it all the way down and convert it to JSON, again, I wouldn't do this, but you can at the point of insertion. And then you install the recipe. So for those of us who aren't Pythonic, make me a virtual env, bring it into my environment, install the stuff I need. Cool. Go build in the things that I need to do in order to do my life. And on the bottom over there, hard example, connect to a Redis, go execute the script that I have written to do that right behind, which means this guy goes into a file, this thing at the bottom goes and runs that file. Done. Congratulations. You've stored your data in real time in a database that sits in memory, that gives you really fast feedback. And I'm actually right. And more importantly, it goes and writes to your Mongo after the fact. So this is the problem that I've encountered. This is really boring. This is code that just goes and pulls all of the ticker symbols that are on the Toronto Stock Exchange. I mentioned America. I'm Canadian. Different countries were kind of like America's hat. I don't know if that happens to you. So we're a different country. We have our own stock exchange. Very exciting. I want to go pull the New York Stock Exchange data in. The NASDAQ hosts the symbols for the New York Stock Exchange, the Amex, the American Stock Exchange, and the NASDAQ itself, the 3 largest stock exchanges on the planet. That's how we get them. It's not exciting, but for those who want to know, I make an HTTP request. I pray to God it's a 200. When it's a 200, cool, I've got some JSON because I'm just going to throw it away because today it's JSON. Go. So this makes sense, right? Look, I get some JSON output. This is what that output looked like in November of last year. 100% realistic. It's not that exciting. The problem is this is what the output looks like if you go take a look today. And today is 3 days ago. Full disclosure, I didn't know it looked like this 3 days ago. I knew it looked like this a while ago, so I stamped that fake date. But you'll notice immediately, well, you probably can't, the sale price now has a $sign. Well, that sucks. Anybody have a pipeline that blew up because now you're getting a string and you used to get a float? That's right. Awesome. Percentages, like my percent change. Well, this is probably a piece of data enrichment. I was probably calculating the difference between my numbers in real time before. And now I can throw that away because it's part of my data feed. That's great. It's yellow. And now my market cap. Dude, that's hard to see. Sorry. My market cap is all of a sudden a float. The market cap used to be an integer. That's a big problem, depending on your language. Like, it's a big problem in Java. It's a big problem in Go. In Python, I don't care. That's not a good thing, by the way. It's just, this becomes a problem depending on how you're storing your data. For those curious, what that tells you is that the stock exchange shortly is going to support the notion of fractional share trades like Robinhood does. The sidebar, like that's what I gain out of that. And then cool, they've now given me a URL to a feed of some sort of data that's available. I don't know what that is, but I can do something with it. So today, my application, my insertion points would have failed because I guarantee you, I have a schema in some sort of database, let's say Postgres, just because we've been saying MySQL. That schema, wizard, well, it used to accept an int, and now my pricing is a string. That really sucks, right? That's where real-time databases come into play. This is a price get. I might have to skip this. For those who want it, here's how you get prices from 2 other stock APIs. The same problem occurred. Dude, 15 minutes? All right, I might skip a bunch. I was worried it was too long. So the same thing happened with pricing data. What you can see here is the last trade time used to be a Unix number of times per second since epoch, 1970. That was a float. That was cool. Oh, wizard, someone gave me an strf formatted string just for time. These are realistic example of how the world lights on fire every single day. That's why this matters. So if we store the data in Redis, and Redis is responsible for replication elsewhere, you know what's going to happen? Nothing. My application will not get the new data, but the data will still be in Redis. That starts to become important because I can find out why is my data there, as opposed to, uh-oh, my data disappeared. But I still have the raw data. That alone is a game changer, right? A lot of the time you end up throwing it away, not intentionally, just things fail. Here's how you store them in Python. It's a set on a thing. If you want to use a hash, which is another data type, so this is, for those of us who traditionally think that Redis is set get, myself included for the record. That's number one. Number two, you want to store it in a hash structure. So this is a structure that takes a bunch of keys and values and you put them in one place. Amazing. Go do that. You want to throw it into JSON because that's the type of JSON, that's what you received. You go do that. But what matters is that Gears will replicate all of these. And when it doesn't, there's a bug, and we fix that. I say we. That ends up being Mayor or me, and I'm sorry. And Felipe laughed. Thanks, bud. So we're going to bulk our changes with pipelines. We talked about that before, just a bunch of SQL inserts at once to reduce the round trip time. What that lets us do is we determine where we're going to pay the cost of that. Using the Redis example even, because Redis is just like everything else, we have a thing called a pipeline. So in SQL, instead of bulk inserting, insert, 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 separated by a semicolon together as a single statement effectively, we add things to a pipeline. So here's a bunch of things. Bam, execute once. And what ends up happening is that execution has a dramatic cost reduction on the network side. So I'm doing the same thing, but I'm saving the network cost. And the network cost is very expensive. If I think about a traditional database, and that, I mean anything that writes to disk ever, 10 times my cost is writing to disk. If I can keep my stuff in memory, I'm fast, I'm scaling, I'm free. That matters because of the cost of enrichment. So using our stock exchange example, there are roughly 8,700 ticker symbols in the North American stock exchanges. 6.5 trading hours, 3.4 million entries a day, 204 million entries, which are ticks per second. So you made a trade, you made a trade, you made a trade, you made a trade. At the end of the day, roughly a minimum of 204 million entries. We're starting to get to a lot. Like, it's not a lot, but we're getting there. So this is what real-time data enrichment is. We transform, make new fields if we need to, update fields if we need to, but that doesn't happen in our insertion point, right? That happens after our insertion point. Enrichment isn't part of the insertion. It's a big key. So here's some examples of when this happens. Using the stock exchange as an example, I'll reduce the awesome. So bids and asks. Today it's sold for, like someone wants to sell for 1,000, someone wants to buy for $999.99. An org wants to have the bid and the ask, so the spread between those, which is a cent, calculated on the fly, because that's how you start to do predictive analytics. That percentage change that we saw in that example, it's a real example. I want to know, did the stock go up or down today, and by how much? Right? Now that's part of the feed. Before it wasn't. Change per share. So you went down 2%, you went up 2%, you went up $1, you went down $1. Market cap. Change per market cap. So most people know Apple's worth, I don't know, something close to $2 trillion. I have no idea. But you can usually get the market cap of something today, but you can't get the market cap of something on a particular day. So you'll find that lots of quants, the folks at Goldman, they're storing that on a per tick basis, and they're enriching it on a per tick basis. I'm not a quant, I don't know what that gives them, but sure, it works out really well. So with gears, again, the idea is you see a chunk of Python, you can go use it. What we will do is for every single key that we have, we're going to go calculate the spread. This is after it's been written, and by that we're taking the ask minus the bid, and then we're going to register it. So all of our data went into Redis, cool. It's making its way slowly over to MySQL, Postgres, Mongo, do your thing. But also now that it's there, I have code that runs inside of my database. And by that I mean I have a series of functions that occur within the context of the database server. They're not elsewhere. They don't wait for transport. They're not running in a Lambda. I mean, my database is here. My code is running here. That is humongous. I saved the network cost, right? I save a lot of the querying cost. I save a lot of the memory transfer cost. Game changer. Schedule backfills, okay, we talked about what this is, and I have like 9 minutes, so I'm going to show you what this is. In Python, there's a library called Celery. Celery is available in Java too. Celery is available in a bunch of things. At the end of the day, you throw all of your tasks together in one place. The most popular place happens to be Redis or RabbitMQ. Your application schedules its job. Great. Your workers, that's what wakes up. That's what scales horizontally. And what that means is they say, yo, do you have anything for me to do? You want me to schedule a backfill? Cool. Oh, you want me to maybe do some enrichment that I didn't do in the database? Amazing. You want me to send a ping over there to those data science people because it happened? So this stops being application-based. It starts being functional-based and running everywhere. I stop worrying about how do I deploy a thing into a Lambda, and I use an ancient pattern. Ancient's like 2010 here. But I start using an ancient pattern so that I throw things into a table. They get picked up by my workers. If I have too many things waiting to execute, I scale out my workers. Plus, I mean, my kids like celery. I don't know if it's a big thing here. So here's how you backfill. This is the Python example. Again, same thing in Java. Connect. Here's how long they run. Give me no more than 10. Number 2, pull in my configuration. That's it. Number 3, I make a task. A task is a function with a decorator. That is all it is. There's nothing new to do. I don't need to learn anything. It hasn't changed in 10 years. It won't change in 10 more years. You write a function to do whatever you want. It receives its context. Life goes on. That's really important from an app developer perspective. Why? Because I actually want to make small surgical changes. I don't want to make massive changes and hope I got it right. But I can start to take a function, and I can have the offloaded version of that function. We can do timed backfills, exactly like we talked about. So we can take an individual task. We can have that individual task run. I think in cron, so I'm glad it does cron, but based on a timing perspective. And it's the same code. You'll see that our backfill is identical to what our backfill was before. And then another Star Wars joke, you can scale out and not up, so you can have clones. Tons of nodes that do caching, tons of nodes that do real-time processing. Your database cluster, you have writes separate from reads. You can do geographic data co-location, which starts to be really important at scale, right? I can put the data that is responsible for you or the data that you need closer to you as the user. A lot of ad networks today, the way they actually work is at the point in time that you log in, your session data ends up copied to the node closer to, series of nodes closer to you, which is one of the reasons that we all have clouds all over the place. So now I can scale experience. My data is closer to the users, just like we talked about. We can distribute the load based on usage. So what does that mean? A ton is occurring right here in Poland. Fantastic. I actually don't know if there's a cloud provider here, so I'm going to say AWS scales up out in Frankfurt, and life goes on, right? It's a different time of day. A ton is happening in Japan. We scale that up. Life goes on. Writing is expensive. Reading is cheaper, so you scale your reads out. Breathe. I need to? Okay, cool. So here's what we did today. Almost on time, nice. Take the Redis mod Docker. Why? Because just like you, I don't want to think. I just want everything in one package so that I can muck around and I can test and I can go. You can't, don't deploy it into prod. But take it, experiment, use it, play with it. That's what we do here. That's honestly, when I do dev on Gears, that's what I do. I use Redis mod. There are 2 different Redis modules that help us do this. JSON for storing JSON, and gears for all of the transactional processing magic that we talked about. RG Hibernate in Java, RG Sync in Python, RG, I don't know what it's called yet in Node, but it's coming, I swear. Then we could use Celery to offload those functions. So we're going to schedule jobs, we're going to throw them in the background. If you are a Ruby person, I don't remember what I think it's called Event Machine or something, but you have your equivalent. So what is important isn't these technologies, right? These are the ones I choose to use. What's important are these ideas. Scheduled tasks in the background that do things on workers that you can spread apart. I use Celery. You use something else. Amazing, but it's the exact same goal, right? The tech isn't important. The idea is important. The code's really important, because why not? So what does this mean we're going to do in the future? We're going to store our data in real time, right? We're going to parse the data. We're going to bulk those changes to reduce the costs of our network. We're going to sample and schedule those backfills. And we're going to scale it out horizontally. No more trying to go up, we're trying to go out. If I have to have 1,500 nodes, that's okay. I can coordinate 1,500 nodes. But it's really expensive if I have a SPOF, a single point of failure. There was a company in Canada that I knew really well, who I guess I can't say the name either. Man, it sucks once you've been in industry for a while. And this company had a gigantic Microsoft SQL server that they called Bertha. Bertha was a custom machine that ran in rack space. I can't even remember how big this thing was. I do remember that it went down, and like, quite frankly, that was 2 days of horrible. And that's why we scale out and not up. And they weren't a small company, like y'all have heard of them. If you have questions, I'm here. That's how you GitHub me. That's how you LinkedIn me. I'm not really great at LinkedIn, I'll be honest, but do it anyway. You want to email me because you want to work at Redis, that's how you do it. And if you want to try the things, you go to that URL, you get a $200 credit for the Redis cloud, and you go do that. We do not have gears, so we do not have this transactional backfill in the cloud. However, in theory, with JavaScript, it comes into cloud this year. I'm also told I can say that. You got any questions? Let's do it. Well, that sucks. I want one. Come on. All right. Thanks, everybody.